it says here, or unit, we're looking at materials, the properties, and uses. Objective: infer that some materials can change from one state to another, and the states would be solid, liquid, and gas. Identify the processes involved when materials change from one state to another, and that would be freezing, melting, evaporating, and condensing. Now we have item type here because we are going to be exposed to many different types of items, and this particular item type is called the selected response or order match. So here we go. We have the item. It says select 4 of the words listed below to complete the diagram to make the relationships true. And our choices are, so we have 4, and we have more than 4 here. We have 1, 2, 3, 4, and 5. So we are going to use 4, so we will always have 1 left. Okay, so we have freezing, evaporation, melting, gas, and heating. Okay, so just looking at this, I see solid, liquid. Automatically I think that gas should go here because this is a state of matter, this is a state of matter, and then here we have gas. So let me type that in right here. So let's go with gas, and that would be there. Let's make this a little bit bigger. Okay, now to help us better understand these relationships, let's go over now and we can watch our video. All right, so let's go with this.
Have you ever wondered why ice turns into puddles of water on a sweltering day? Keep watching and you'll find out. On Earth, materials exist in one of 3 main states of matter: solid, liquid, or gas. Materials can change between these states. When a state change occurs, a substance's property will also change. Maybe not too surprising. However, if the state change is reversed, the substance will recover the properties it had to begin with. Neat. Matter can transition between the 3 states when heated or cooled. But why is heat key in all of this? When a material is heated, it absorbs heat energy. This additional energy can cause attractive forces between molecules to break. This leads to rearrangements of the particles because the attractive forces no longer hold them together as tightly. The same happens when a liquid is heated. The attractive forces between the molecules break, leading them to become more widely dispersed and a gas to form. These 4 words describe changes in state. Do you know which word refers to which change? Pause the video, fill in the gaps, and click play when you're ready.
Alright, so let's do this one. Let's go now. We have 1, 2, 3, and 4. And the words are freezing, melting, evaporating, condensing. So we have here, we're going to use our common sense. So when water is in solid form, we call it ice. And from ice to liquid, we could call that melting. Not true? Yes. So we leave the ice outside. It will gain some heat and will change state from a solid to a liquid. And we can call that melting. So I think we could put melting here for sure. Then change of state now, we have liquid, and if we leave this water outside, eventually it will disappear, and that process is evaporating. So it gains more heat, changes state from a liquid to a gas. Then let's go now, and we're going 4, then 3. So from gas back to liquid, that would be condensing. For example, we have clouds in the air, and when those clouds, which have water vapor, cool down, then we can get the water liquid back out of it. And then when the liquid water, and of course this is losing heat, from here to here we lose heat. You notice from this way we are gaining heat, and this way cooling is what? Losing heat. All right, so we go from water now back to ice or solid water. So that would be freezing. So let's see if we have gotten those.
Did you get them right?
All right, let's look. So yes, we have melting, yes, evaporating, condensing, and freezing. So we got everything there.
Do you know the difference between evaporation and boiling? Both are when a substance transforms from a liquid to a gas. Think of a boiling pan of water, all of the water bubbles. This is because all of the particles have enough energy to become gaseous. But water standing in a pan that is not being heated by anything other than the environment can also turn into a gas. This is evaporation. Only the particles at the surface have enough energy to change from a liquid to a gas. Hence, evaporation is a slower process than boiling, even though it achieves the same state change. Both are types of vaporization. The opposite of these vaporization processes is condensation, the transition from a gas to a liquid. Think of a cold can of soda on a hot day, those water droplets on the outsides, or the dew on the grass in the morning, or the steamed up mirror after a hot bath, even the clouds in the sky, or a foggy windscreen in a car. These are all examples of condensation. Water vapor in the air has cooled down to form liquid droplets of water. Now let's think about the transitions between solids and liquids, so melting and freezing. Think of the Arctic sea ice. In the summer, when air temperatures are warmer, more heat energy is absorbed by the ice. This causes bonds to break between the ice's water molecules and the ice starts to melt. The solid ice becomes liquid water. But in the winter, the air temperatures are colder, and so seawater freezes, and the ice starts to form again. There is less heat energy within the ice, and so more bonds can form, holding it together as solid ice. So far, so good. But did you know that sometimes when solids are heated, they can turn straight into gases? This is called sublimation.
Let's pause here and think about this. So something can go directly from a solid to a gas. The example that they often use is that of dry ice. Okay, now dry ice is carbon dioxide in solid form, and dry ice is used by people who sell like ice cream. You want to keep that ice cream nice and cool or frozen to make sure that when you're serving it, it's in a state that people want, right? And they use that particular thing to keep the thing cool. Now, dry ice is not the only thing that can sublime. You could also have mothballs, or what we would call camphor balls. We put them in the drawer, and people like to say this gives it a certain smell. They're used to keep moths away. But have you ever gone into the drawer and seen the mothball with liquid around it? No, it changes state from a solid directly to a gas. Okay.
This is only demonstrated by particular materials such as solid carbon dioxide, also known as dry ice. When subjected to a certain pressure, it will turn straight into gaseous carbon dioxide. Liquid carbon dioxide does exist, but it only occurs under very high pressures. Similarly, gases can turn straight into solids when cooled. This is called deposition. Let's check out how much you remember about the changes of state. Pause the video and fill in the blanks.
Alright, let's go with this one and see. So solid directly to gas. Okay, so that one would have been sublimation, right? And the opposite of that, that's 2. When we change it back from gas to solid, that's deposition. Alright, let's go with 3 and 4. We're going from gas to liquid, so that's cooling it down. So this would be condensation. Alright, and we're going from liquid to gas, so this is evaporation. Alright, so these are vaporizing. Alright, let's go now to 5 and 6. We go from solid here to liquid, and this would be melting. Okay, can say melting here, and then now from liquid to solid, that's freezing. All right, let's see how many of those we got.
Did you remember them all?
All right, hold on, let's pause. So 1 sublimation, yes. deposition, yes. Condensation and evaporation, cool. Melting and freezing. All right, great. We got all of those.
Our final thing to discover is that when a material changes states, the mass stays the same. The density changes, so the mass per unit volume, but the mass does not change. Our glass of nice cold Coke weighs the same whether the ice is solid or when the ice has melted. So there we have the changes of state. Just remember that the mass stays the same whatever the state.
If you liked the video,
Alright, hold on. Let's jump back a little bit to this. They said the mass stays the same. So this would be a lovely investigation for us to do in class. We could weigh some ice, and then we could observe after it melts if we have the same weight, because this says that the mass stays the same, and mass means the amount of substance that can be found in a particular thing. But the density has to do with the arrangement of the particles in that particular thing. So the density may change, meaning that as a solid, the particles are more closely arranged than if it were a liquid, where they are less dense. And as a gas, it's even less dense than a liquid. Okay, so this is something that we could try in class. All right, so let's get back to our activity here and just finish up this part of it. So let's go now. So solid to liquid, and then liquid to gas. Now I see condensation here, so automatically the opposite of condensation based on what we did would be evaporation. All right, so this needs a little adjusting. Okay, so let's fix this up and make it neat. Important for us to put our work neatly on the paper. And so we have used evaporation, we have used gas, so we have melting, heating, and freezing. So let's go this way first. All right, so we have a liquid, and we're going to get it to a solid, and I'm thinking of ice. Oh, that would be freezing, so let's put freezing in here. All right, and then the opposite happens because it's going the other way around, and that would be melting. Not true. From solid, from the ice to the liquid, that's melting. All right, melting. Okay, so this looks like we're complete. Let's test it to see. In the middle, these large rectangles here, they would have, or what, states of matter. We have solid, liquid, and gas. And now we say we started here because this is the first thing we had. We had condensation, and the opposite of condensation is what? Evaporation. And our video said this is dealing with what? Vaporization. All right, so we're changing vapor to liquid, or we're changing vapor to gas, liquid to gas. All right, so vaporization happens here, and here we have melting and freezing. So when we go from a solid to a liquid, that's melting, and when we reverse that, we go from a liquid to a solid, that's freezing. And all of this has to do with heating and how we do what? How we relate these substances to heat. All right, guys, I'll see you in the next episode.